Welcome all. Today we are going to take up a very interesting session, which is widely used, which is widely asked in interviews. I am very sure after watching this video, you would be an expert in the top inquiries. I'll make sure that you would be able to solve any kind of top inquiries, be it in your work, be it in your interviews. So let's start. So what I'm going to do is, so I have created 3 different set of queries that we'll look into and different ways to achieve that. After going through all this, I am pretty sure you would be able to, rock and roll in any kind of top inquiries. So let's start. So first is, I'll just show you the data. What is the data that we have? So this is our employee table. Okay, it has 14 rows. I have taken this in the Excel sheet also, as you can see here. Okay, so this is for the whole organization. Now, what I'm going to do is, we'll start with the first set of queries. So, finding the highest earning employee in the organization. So, yeah. So the first method that we'll take is, say, dense rank. Okay, we'll use the analytical function. It's very simple. If you know analytical functions, how to write analytical functions, your life is easier. There is nothing like it. So I'll explain while I'm writing. So first I fetch data from the table. Okay, here from the employee table, now I'll do the ranking part. Okay, I'll do the ranking part, dense rank over. So this is the highest salary that I'm looking for in the organization, right? So there will be no partition, there will be no grouping that I need to do. Simple. Just keep this in mind. If I am I'm finding the highest salary in the whole data set, then there will be no partition. But I need order by, right? The ranking needs order by. So I'll just add the order by, and order by is on what? Earning. Earning is salary. So salary. Highest. Highest means it will start from descending. So why descending? Okay. We'll do ranking here. Once ranking is done, we'll make this as an inline query. You could write in this way also. It makes query more readable and understandable. So here you can just filter rank equals to 1. Okay, and you would get the employee with the highest salary. So in our data set, as we can see, so this is in ascending order of salary. So this is the employee that we should get after running this query. So let's run this. Okay, so it's president. The salary is 5,000, department is 10, rank is 1. Okay, so it's very simple, right? So we do ranking on the whole data set. Okay, we do ranking, and once ranking is done, we get all the ranks. So if I just run this part of the query, okay, you can see here there is 1, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Okay, so I have done the ranking, and once ranking is done, and then I can choose whatever rank. So because I'm looking for the highest salary, since I have done salary descending, right? So I will get the highest salary. Simple as that. Now look at the other. We'll try and Rownum. We'll use this method, Rownum. So this is another method of getting the highest salary. Okay, I'll write here VT as. This is another with clause or query that I am creating. I'll fetch the data from the employee table. Now what I'll do is, I'll order by salary descending. Okay, once I do this, and if I just retrieve the data set, okay, so you can see the data is ordered by salary descending. Very simple query. Here I'll just do Rownum equals to 1. So I'll get the first row. Fine. So we get the same output. Now I'll tell you why we shouldn't use Rownum or rank. We have used dense rank, not rank. So why we should not use Rownum or dense rank for the top inquiries? First, let me just cover all these methods. So there is one more. There are 2 more actually. So let's complete that. We will use offset and fetch. Okay. Again, same thing. We'll just take this query. So you do descending by, and once descending by is done, I will fetch first row only. It's very simple. I'll just for the output sake. Okay, it's very simple. You first do the order by salary descending, very similar to this, and then you just fetch the first row. That's it. Now we'll look at the last method, which is like using the correlation or subqueries. Using the correlation and the subqueries. So how can I write this? Okay. So first thing, I'll get the maximum salary from the employee table. So how can I get that? Simple, max of salary. Now the next step would be just fetch it from employee table where salary equals to, we are using the subquery here. Okay, so this becomes the input to this particular query. I'll get the maximum salary and I'll pass the maximum salary to the outer query. As simple as that. Nothing complex in this. Very simple, straightforward. So just formatting the query for understanding sake, and what I'll do is run this query so that we see that the output is actually executed. Okay, so we get the highest salary here. There is another method, but we will cover in the other questions. Now, why we should avoid Rownum? Okay, let me write why we should avoid Rownum or rank or fetch kind of queries for Top-n. Why? Now let's look at this example. Suppose I'm just adding a dummy query, dummy data here. Sorry, I'll just add it at the last because I'm looking at the highest salary. Suppose this is net one, clerk one, something like that. Okay, and then say the highest salary, there are two employees. There are two employees with the same salary in the organization. Now, if I have this kind of data, what Rownum would do? So I do a order by. So this becomes my first row. So let me do it. I'll just sort here, sort by salary, and I'll do sort by salary, largest to smallest. Fine. So I can see here there are two rows with the salary 5,000. Ideally, my output should return these two rows. So what will happen in case of Rownum? So Rownum will assign rows like this. Okay, and when we put the condition here, Rownum equals to 1. So what will happen? It will give only this particular row. So that's an issue, right? But we should have actually got two rows. So that's the problem with Rownum. Now let's look at the other one, rank function. What rank would do? Since it is first, actually this will work fine. But say suppose if I am looking for the second rank queries, okay, or the fourth rank, it will not be fourth, it will be 1, 2, 3, 4, 5. Okay, so for now I'll just remove this one. So rank will create this kind of data. Suppose if I want the employee who has the second highest salary, but do we find here the second highest salary? Rank will return no data, but that's not correct, right? That is why we use dense rank. What dense rank will do? Dense rank will create this kind of data. It will not skip. And then when you put dense rank equals to 1, you will get 2 rows. 2, you will get 2 rows. So that's the reason why we should avoid rank and dense rank. Rank function, and you should use dense rank because there are gaps actually in the ranking. And then fetch and offset, very similar to Rownum. You do a descending here, and once descending is done here, and then you would find that you are fetching only this particular row, not both the rows. So I hope this part is clear. Now what? So 1, 2, 3, 4. So like you can see, there are multiple methods of getting this data. So there is one more method that you could use and you should avoid again. So I'll just add it here. It's very similar to dense rank, but the output is like Rownum. So it's like the row number analytical function. So we use row number analytical function, we will get the same output. See there, we'll get the same output, but the issue, yeah, I'll just add here, don't use row number also. Why row number should be avoided? Same thing, it will do ordering, but then if there are same salaries, right, then we should return two rows, but it will return only one row. So that's the problem with row number also. It's very similar to the issue that we have with row number, Rownum, offset and fetch. Fine. Now let's take the next one. I want to find the lowest earning employee. Now this should be very straightforward for you. I'll be very quick on this one. So dense rank, to get the highest salary I did descending and took the rank 1. Now I'll do what? Ascending. Just see the data here. Okay, now it will start from the lowest salary as rank 1 because I have put order by ascending. Simple. And then I'll just use this rank 1. I will get the employee with the least salary. Same here for row number. Same. Yeah, same. Rownum, ascending. Fine. Same here, ascending. Now, in the correlation of subquery, what would be the thing that you would do? Instead of max, what you will find out? The minimum salary. First find the minimum salary in the employee table and then just try to, right? See what will happen here. First we run, we get the minimum salary. Now we pass salary equals to 800. So what the employees with the salary 800 is displayed. Simple. So that's how the correlation of subquery will work. So now we have covered two queries, lowest and highest earning in the organization. Now let's find out the third highest earning employee in the organization. Now again, this should be very simple. Okay, order by salary, descending. Perfect. Why descending? I want highest salary, so invert it. So the highest salary will come first row, next, second, and let's find out the third one. It's done. Okay, so the third highest salary, so I get your third highest salary. Now we'll just verify in the Excel sheet here. I'll just remove this row here. This was added by me, sorry, not this one. This one. Now let's start. Which is the third highest salary? 1, second, and third. Right? This is my third highest salary, and this is what I'm getting. See what will happen. Order by salary is saying you will get this kind of data. So dense rank will do 1, 2, 2, third, and then we just do a filter from that output. Correct? So this is the with clause or this query or subquery that would run, and on top of that we just filter the row with rank equals to 3. Right? Now you can find any nth salary, nth highest salary, nth lowest salary. You just need to do some modification here and there, and you would be ready with your query in few seconds. Same here, descending, rank 3. I'll be quick here. I am hopefully now what? Okay, so Rownum. Now you'll get the you'll see the difference, right, in the output. Okay, see, sorry, not Rownum equals to 3. It's a wrong query. You cannot put Rownum equals to 3. So what you would see is I'm getting this salary descending. I should do one more thing here. T dot star. Okay. After this, I'll just add one more. Select star. Say this is T dot star, comma, Rownum, and I'll give this row number from. Okay. This whole subquery is T, and it ends my not T. I should put it as Q. Let's put it as Q. Okay. Now we'll see the output. Oh my god. Fine. So what I did was, first I did order by salary descending, correct? And then on that output, I just added the row number. So I got the RN or the row number column. Because I cannot do row number equals to 1 or equals to 2, 3, 4, 5. I can do row number less than equals to something. I cannot do row number equals to. It's a pseudo column, right? So we cannot do that. So for this reason, I added it in the subquery. Now, what I'll do, very simple thing, rn equals to 3. Now if I run this, oh, you see the output is 3000. Why? I explained you few minutes back. Row number will do what? 1, 2, 3. So it will return this row. So it doesn't look into the distinct part, and that is why I told you that we should avoid using Rownum, rank, fetch, and row number. You will get similar kind of output. But for the sake of understanding and to learn and be an expert in writing different kind of queries, I took this part. Okay. Now in the fetch and offset, since you want the third one, right? So it is like offset. First you choose the offset. Third is what? Third row. I want the third row, you could say. I want the third row or the third highest salary. So third is n. So n minus 1. So 3 minus 1 is 2. Offset 2 rows, fetch next 1 rows only. Fine. So it would be the similar output that you would get with the row number. So these three will have the same output. But correlation and the dense rank will give you the correct output. Now in the case of correlation, this won't work, right? I want the third highest salary. This will give me the minimum, that is the first one or the third one. So how do I write a query for this? So this is a bit interesting. So first let me change the alias. Let me make it as E and E1. Here I go. So first what I'll do is I'll compare the salary E1.salary is greater than equal to E.salary. So what this E, say suppose it changes the first row, okay? It changes the first row, say 5000. So in this it will try to find out. So I'll use this count of distinct salary. So it will say 5000, okay? How many employees are there, okay? So how many distinct salaries are there? You could say how many distinct salaries are there, which are basically, so where E1.sal, where basically how many distinct salaries which are greater than 5000. So something like this. So you would get the count. So come here and let's look at the data. So when I pass 5000, okay, this 5000 will be from that outer query, okay? 5000 will be passed. Now it will do a count of distinct salaries which is greater than or equal to 5000. So in this data, there is greater than or equal to only one 5000. There is only one 5000, right? So greater than or equal to, the count would return as 1, right? I'll just run this. See, I get the count as 1. Now say I'll take 3000. Okay, I'll take 3000. What will happen here? See, count is 2. So why are we getting 2? Just let's remove this. So I'm getting 5000 and 3000 because there is equal to, right? So even 3000 is considered in this. So you would get the salaries in the employee table which are greater than or equal to 3000, which is coming from this outer query in our case. So now you got the count. Now this count should be, so what I'm looking for, the third highest salary. So I'll pass just 3. So whatever n that you want. So third highest salary, correct? So this you would get from, you will get the third highest salary, which is 2975, and this is the perfect and the correct output that you would get even from the dense rank. So you should always use dense rank or this kind of correlated queries. And there is one more way to just verify your data. Say like what was the count of distinct salaries, I'm not able to understand, or something like that. You can just paste it here as scalar query, okay? And then you can just take the output. So I'll just remove this condition here. So I'll not remove it, I'll just run this part. So here you can see, and I'll do one more thing. I'll do order by count. Let's do order by count. See, here you can see how many salaries. So I'm buying 5000. How many salaries or how many employees are there with salary 5000 or greater than 5000? Only one. 3000, 2, right? Greater than or equal to 5000 and this one. 2975, 5000, 3000 and 2975. So 3, 2850, 4, 2450, 5. So and what did I pass? 3. So I'm getting this output, right? Hopefully this should help you. This is a bit complex actually, because there is a bit of correlation, and you have to apply your mind a lot. But then I think after this, it should make your life easier, even writing these kind of correlated queries. And then you can just do these kind of verification which I showed you separately. Now I have found the third highest salary earning in employee. Okay, now let's find third. So lowest salary, it would be quite straightforward, right? So let's do the third lowest salary, third lowest earning employee. So how can I do that? Very simple. Just do ascending. Why ascending? So go here. I do a data sort from smallest to largest. I do a ascending here. Now once I do ascending, what happens? Bench rank 1, 2. I will pick up this one. I get the lowest salary. Simple. Yeah. So we get the rank third. So I have the third highest salary, third lowest salary. Sorry. 1, 2, 3. So this is our third lowest salary. See, if I put fourth lowest salary, just for the sake of understanding, see, I am getting 2 rows. If I am taking fourth salary in case of row number, see, you will see only 1 row. See, we see only 1 row. I have explained you now 2 or 3 times now why we should not use row number. This is the issue that we will see. Okay, we should have these 2 rows. This is the correct output. Sorry, my bad, I didn't do ascending there, but still you would only get correct. Come here in the Rownum. See again, offset and fetch. So offset and fetch, again do ascending. Fourth highest salary, 4 is n minus 1. 4 minus 1, 3. Fetch what? Only 1 row. Then 1 row. Correlation query. Now I am looking for the lowest salary. So what should I do? For the highest salary, I am checking how many, say I am passing 5,000. How many employees have salary greater than or equal to 5,000, equal to 3,000, greater than equal to means more than that, or the higher earning. Now to make it lower, I'll just do less than equal to. Let's run this. Let's make it 4 here. I should have I should have 2 rows. As you can see, there are 2 rows, correct? So this is how you can do this. Let's take the another example, third, and to find employees, highest employees. So let's take this example. Find third to sixth. Okay, let's try to find this one. So I want to find out the employees who are basically ranked third, fourth, fifth, sixth. Okay, as far as earning is concerned. So this is also very simple. Let's first do it descending. Why descending? Highest earning. So salary should be descending. So the ranking, the highest salary will get higher ranking. Okay. Now I want between what? 3 and 6. Right? Between third and sixth highest. All the employees, right? So here I can see third, fourth, fifth, sixth in the output. Okay. Let's just verify here. I'll just change this. Okay, 1, 2, 2, 3, 4, 5, 6, it should be 7. So these are the rows that I'm getting in the output. Correct. Now, in case of Rownum, as I told you, you will get different kind of output, but syntax is very, very simple now because we have already solved the other kind of queries. See here, third, fourth, fifth, sixth. Done. Same here. I'll just copy paste now. Okay. But in case of row number, since it doesn't consider these unique values as same rank and it skips basically, so you will get different kind of output, which is actually incorrect output. Now, what is in the case of offset and fetch? So what do I want? From third, right? So n minus 1. So starting point, n minus 1, 2. So skip the first 2 rows. Okay. Now third, fourth, fifth, sixth. So how many rows? 3, 4, 5, 6. 1, 2, 3, 4. So fetch only next 4 rows. Start from the third row and fetch next 4 rows. So that's how offset and fetch will give you the data. So this is the data, right? So this is returning lowest earning, or the third last, fourth last, fifth last, and sixth last. But now I've changed this. Okay, this is clear. Now let's take the other example, the correlation, the another method, correlation. So how will I do here the correlation query between third and sixth? It's very simple. Just do between 3 and 6. No change. Okay, because I need higher earning salaries. Just change this, and here is the output. Okay, third, fourth, fifth, sixth. You will get the correct data in this way. I have explained this count, distinct, everything just in this video itself, so you can just go through it once to understand it. Now, what I'm going to do is I'm going to take this example, third to sixth highest, now in the department itself. Okay, as far as department is concerned, or let's first start with the third. Highest earning employee in the department. Let's find this in the department, right? Now what I'm going to do is in the department. So I have this department number 1, 2, and 3. So I want to find out the third highest employee, or the third highest earning employee. Third highest earning employee in the department. Okay. So in case of dense rank and everything, when I don't do a partition, it will consider everything. When I do a partition, that is a group by, so it will create the buckets or the group bys. So now I can just put equals to 3. Simple. See there, you get the third highest salary. So you can put any second, first, or the maximum salary is first highest salary, second, third, fourth, fifth, whatever you want in the department. So I'll just explain here in the Excel sheet once. So what dense rank will do in case of department here. So third highest means 1, 2, 3. Again. Okay, first let me just sort it properly. Okay, largest to smallest. Perfect. Now 1, 2, 3. Now what will happen, because I have used partition by clause, just see this part, because I have used partition by clause, it will reset the counter, reset the ranking here. It will start with 1, 2, 3, 4, 5. Again, it will reset at 30 because it's a new department. 3, 4, 5, 6. Simple. 5,000, and this is 3,000, and 2850. This is the output that we are getting. Come on. Sorry, this is third highest salary, but I was talking about this 1300, 2450, and 1500. So this is the output. Okay. Now let's in case of row number, so we can actually skip this part. We are not going to do it by row number. Row number and offset will not be used in this case. In the case of if there is a bucketing or there is a grouping by that we need to do, we can use this row number analytical function. So I'll just remove these two. So I'll use a partition by department number, and rank is 3. Okay. Here is the output. I just show you how the output of the row number is. So this is the output of the row number, and then I just filter it with the rank. Now the most interesting part is the correlation subqueries. How can I do a grouping by year, or basically bucketing? Okay, it's very simple here. It's very simple. It's a correlation query, right? So earlier employee, it was checking in the whole set. Now I'll just check in that department to which it is belonging to. Now I'll just do this particular condition. I'll just add this particular condition. Once I add this particular condition, work is done. There is nothing to be done. So any number of bucketing that you add, say department number, job, if there are multiple conditions, just add these conditions in the correlation. That's it. And then instead of between, I'll do equal to 3, and I should get the output which I had got using the dense rank, as you can see, right? And similarly, if I want to find out between 3 and 6, just put between 3 and 6 in that department. Between 1 and 2, I'll find between 1 and 2. So this is how you can solve all these top-n queries using different methods. I would prefer dense rank. Dense rank is simpler. You can use correlation query, but then there would be a performance impact on this one for sure. So you can avoid this. Row number won't give you the correct one. So dense rank is the perfect methodology that you should use. That's what I would prefer. It's very simple as well. But then you should know the other ways of writing queries. So with this, I end this session, and I hope you will be able to write any kind of complex queries related to top-n queries. Plus, if you are appearing for an interview, then I'm pretty sure that if there is a question by the interviewer, then you can give all these different methods and why you shouldn't use Rownum, or other, and why you should use dense rank or the other one. You will have all the answers now. Thank you.